This video lesson is on tree diagrams without replacement. All right, so tree diagrams without replacement, we have the second event being dependent on the first event. So now B actually has to do with A in some way. We also treat simultaneous events as the same as without replacement. So an example of that, instead of thinking of like marbles that you pull out of a bag and you don't put back, you're literally not replacing it. Another option is I draw two cards from a deck. So it would be the same as if I pulled a card and then pulled the second card without replacing that first. But because I'm happening at the same time, it's the same kind of situation. So let's do an example. We've got a bag containing 5 green and 6 red balls. If 2 balls are taken out right after each other without replacement, with a hilarious typo, what is the probability? And then we're going to answer some questions. So let's first break this down into the without replacement situation. We've got a bag and it has 5 green and 6 red balls. So that means there's 11 balls in this bag. The first option is we pull a green ball. The other option is red. These are mutually exclusive. They're the complement of each other. So remember, complements, it either happens or it doesn't happen. So that's the same as saying I pull a green or I pull a red. There's no other options here. So if I'm not pulling green, I'm pulling red and vice versa. So the probability of pulling a green would be 5 out of 11 because we have these 5 green, we have 11 total. And then the probability of pulling red would be 6 out of 11. 6 red balls, 11 total. The issue is with this without replacement situation is that I'm not going to put it back. So if I pull a green, that changes the whole situation. I no longer have 11 total balls if I take one of them out. And if I pull a green, I don't have 5 anymore. So this is where it gets super wonky. So first let me go fill out the rest of this situation. So we could go green, 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 red, red, green, or red, red. Filling out the probabilities is where it's tricky. So we have to really think about what's going on. If I'm following this path here, so I hit the green ball, the next step could be this other green ball. So now I need to think, if I have pulled one of the green, I don't have 5 anymore, but I have 4 green balls left because I pulled one of them out. And I no longer have 11 total, I have 4 total. So we're going to subtract one of those greens out, and we're going to subtract the total ball count. For the red situation, we're following green and then red. So that means we pulled a green, that happened, we got a green ball. So that means I still have all 6 red balls, but there's only 10 total. And I want you to notice that this combination here should total up to 1. 4 tenths and 6 tenths is 10 tenths. So that should be happening as we build these, just like 5 elevenths plus 6 elevenths is 11 elevenths. So now let's go down this bottom path here. So now ignore the top stuff. We're going to go down the red track. So the first one we pick is red. Let's figure out what the probability of picking a green one is. So if we picked red on the first one, then that means we still have 5 green balls because we did not pick one of those greens. But we took out a red, so now there's only 10 balls. Now let's keep following this last one. If we pull a red first, that means there are only 5 red left because we pulled out a red and we did not put it back. And the total is 10. So now this section, the brown probabilities, also totals 10 out of 10. We've got 5 here, that's 10 out of 10. So now we've built all of these branches, and let's remember that the total probability of both things happening as we follow each branch, we're going to multiply those probabilities. So I'm going to do 5 elevenths times 4 tenths and get 2 elevenths. Then we'll do the green-red option. We multiply 5 elevenths times 6 tenths. We get 3 elevenths, and then I'm going to keep going. So then the red-green was 3 elevenths, and the red-red was 3 elevenths. And again, if we were to add all of these up, 2 plus 3 is 5, plus 3 is 8, plus 3 is 11, out of the 11. So this should total 1 when we follow all of these options, because we are now sort of listing out the sample space here. We could go green, 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 red, red, green, red, red. Now let's answer some questions. So we've got problem A, at least one green ball is chosen. So in order for us to get at least one, that means we could follow the green, green path. So that could be this one here. We could follow the green, red path, which would go here. Or we could follow the red-green path because it doesn't say which ball needs to be green. It's just saying at least one is green. So really that's just saying everything but getting both reds. If we have one green somewhere, we ever hit a green, that works for us. So let's add up these three fractions. That's going to give us 8/11. So the probability of getting at least one green is 8 out of 11. That's pretty likely. This next problem is asking, what if red is picked first? So just what's the probability that you pick red first? In that case, it doesn't matter what happens after that. So really, we just want to pick the red and then do something else. Okay, so that is going to be a total of these two here, which would add up to 6 out of 11. And really, it's just that initial piece. What's the first option where you pick a red? It's 6 out of 11. It doesn't matter what happens after that. All right, we've got one more problem. Go ahead and read this to yourself. All right, so something that's weird about this problem is that really we only care if we have an even or odd. We don't actually care if it's 1, 2, 3, 4, or 5 when we pull a ticket. We're just looking at even versus odd. So those are going to be our two events. So our options are, first we pick an odd or we pick an even, and then same. We can pick an odd and an even after that, or an odd and an even after that. And the big thing is that we are not replacing, so without replacement. So we're going to have to do some subtraction at each of these probability levels. So let's first start with picking an odd. At the beginning, we've got 5 total tickets, and 1, 3, and 5 are our 3 odd options. So that means we have 3 out of a 5 total option here. And then even is going to be the remaining 2, because we had 2 and 4. And remember, these are complements, either your odd or your even, so the total sum of these should be 5 out of 5 or 1. Now let's think about if we went odd, odd. So that means we pull one of the odds, we pull the 3 out, right? That means there's only 2 odd cards left, and there's only 4 total tickets here. So we started with 3 odd out of 5 total. When you pull that first odd out, there's now only 2 odds and 4 total. For the even option here, we've gotten an odd ticket out, so that means we only have 4 total tickets, but there's still both 2 and 4. We still have both of the original even tickets. The next round would be we could go even and then odd. So if we pull an even card, that means we still have all of our original odds, but there's only 4 total tickets. And then lastly, even, even. If we take one of those evens, that means there's only 1 even left, and there's only 4 tickets in total. So now we're going to do our multiplying across each branch to figure out the total probability of both events happening. So I'm just going to multiply along the branches. So after multiplying along each branch, I got these probabilities here. If we add them up, we should get 1, and we do. So now let's answer these questions. We want to first find what's the probability that both are odd. So that would be to follow this odd, odd path only, and that's going to be this 3 out of 10 at the end. Problem B is asking, what about both being even? So that would be to follow this even, even path, which we get 1 out of 10 in the end. Lastly, what if one is odd and one is even? So that means we could go odd, even, or we could go even, odd. So both of these probabilities are going to give us the answer to C, so we're going to add those up. That would be 6 out of 10, which simplifies to 3/5. So those are our final answers to these 3 questions here.